Following up our previous notes where we graphed piecewise functions, in today's notes we're going to look at writing piecewise functions from an already existing graph. So just a reminder, piecewise functions are functions which are broken up into sections, and each part of the function tells you what line or function to draw and in what region to draw it. And we'll be indicating that with values of x. So if we look at the first one, essentially what we're going to do is look at each piece of the function, decide what that equation should look like, and then we can put together the actual total piecewise function. So first, what you want to do is look for the point or the line where the graph changes. You can see here on this one, it's this line right in the middle, the y-axis. And so we know that that is the line where x is equal to 0. So everything to the left of this line, this portion of the graph, is where x is less than 0. And this portion of the graph is where x is greater than 0. So that will help us when we go to write our piecewise function, indicate which side of the graph our line belongs to. Now let's look at the individual lines. So the left-hand side here, the red line, starts at 5. So we know the y-intercept is 5, and it has a slope. If we go down to left 3, has a slope of positive 2/3. So remember, slope is usually considered from left to right. So instead of going down 2, left 3, we could also go up 2 and right 3. Either way, that's a slope of positive 2/3 x. Okay, so that would be the equation of that red line if it was just on this graph by itself. For the blue line, starts at -2, and we have a slope of 1, 2, 3, 4, down 4/1. So a slope of -4. Okay, so we have our two equations, y equals 2/3 x plus 5, and y equals -4x minus 2. And now we can build our piecewise function. So remember, the way these are formatted, we start with the function name f of x. Then we're going to have two lines inside this bracket. Okay, so typically you start with the one that is less than 0. So we know that the function equals 2/3 x plus 5, right? We just used the part after the equal sign because our equal sign is right here. And that function, that line, exists on this graph if x is less than 0. And because we have a filled in circle, it's less than or equal to. And now we just use our second line, f of x equals -4x minus 2 if x is greater than 0. And we don't put the equal to bar because we have an open circle on that line. All right, so that's the process I'd recommend. Find your transition point, the vertical line where your graph changes, and then just consider each half of the graph, figure out what the linear portion of that is, and then build your piecewise function. Let's look at the second one. Looks like we have the same line there in the middle where x equals 0. And so again, we have the left-hand side where x is less than 0 and the right-hand side where x is greater than 0. And so for our red line on the left here, it starts at 0. And it looks like it has a slope of -2/5. So our equation is -2/5 x and then plus 0, but you don't have to write the plus 0. So we can leave it like that. And then for the blue line, it starts at 3, and it looks like it just has a slope of 1, up 1/1. That's y equals 1x plus 3. Now, I wouldn't say that you have to write the equations on the graph like I just did. You could just write them as you build your piecewise function. But for the purposes of the notes, I like to be as clear as possible. So for our piecewise function, we know that f of x is equal to negative 2/5 x when, or if, x is less than 0, and we again have an open circle, so we don't need to put the equal to bar. And f of x is equal to x plus 3 if x is greater than or equal to 0, because we are filled in circle there, so we want to include 0 in that solution set. All right, let's keep going. Now the next one, we are again changing here at 0. So x equals 0 is our change line. Let's see if we can build the function without writing the equations on the graph, just in case anybody would prefer to do that. That's okay. So we have f of x equals, and now we have to figure out, I don't know why I'm having trouble with this bracket. We're going to figure out what our equations are. So for the less than 0 half, we start 1, 2, 3 at negative 4. And our slope is negative, right? We're going down to the right. So let's just pick 2 points here. Looks like it's pretty consistently down 2/1. So we have negative 2x minus 4. That is the linear function for the red line, and that is if x is less than or equal to 0. And we know it's less than or equal to, even though they look like they're on the same spot here. The red circle, so luckily these two lines are color-coded, so we know this one is or equal to because it's filled in. Now because this is a function, and to be a function, you can only have one output, one y value for every x value. I can't have x equals 0 and get two different numbers. So this next function is going to have to be just greater than 0. So essentially only one of them should be or equal to. Okay, but the next one is just a horizontal line at negative 4. So that's just f of x equals negative 4 if x is greater than 0, right? It has a slope of 0, so it's just a constant. Okay, and for our final example here, looks like our line where the graph changes is not at 0. This is at the point, or the line x equals 4. Okay, so let's see if we can figure this out. First of all, I have f of x equals something. And let's figure out the less than. Well, it's just a horizontal line again down here at negative 2. So the function is equal to negative 2 if, and it is filled in again, x is less than or equal to 4. So I have a filled in circle, so I use the equal to bar. Now the blue line is going to be a little trickier to figure out. We can figure out the slope is negative 1/2. But I need to find the y-intercept. So I should follow that slope, right? Negative 1/2, up 1, left 2, until I get to the y-intercept, which is 3. So I know that it's negative 1/2 x plus 3, and that's if x is greater than 4. I'd like to line those up a little better. Okay, so if your line is not at x equals 0, if your change line, the line where the graphs change, if it's somewhere else, you'll have to work backwards or work forwards, or work off the line to figure out what the y-intercept is, so you can actually write the equation. Because if you don't know the y-intercept, you can't just use where the line crosses, this line of x equals 4. I couldn't just use this point as the intercept, because the way slope-intercept form works is it relies on the y-intercept. So we have to figure out where that is. And in this case, it was right here at 3. Okay, so that's the process for writing a piecewise function. Figure out where your function transitions from one to the next, and then look at each half of the graph, figure out what the equations of those lines would be, and then you can use all that information to build your piecewise function.